All right, today we're tackling one of the wildest things in the entire universe, the black hole. And we're going to see how these things don't just, play by the rules of physics, they seem to completely rewrite them. So let's just jump right in. Okay, let's start with a big one. You've probably heard this before. Can anything break the speed of light? I mean, that's like the ultimate speed limit in the universe, isn't it? And the simple answer is nope. Just a flat no. Nothing that has mass can even get to the speed of light. Never mind go faster. It's a hard-coded rule of the cosmos. But, and this is a big but, that's not quite the whole story. This is where your brain's going to start to hurt a little bit, in a good way. See, a black hole does something way, way weirder. It doesn't beat light in a race. No, it breaks the racetrack. It shatters the very path that light is traveling on. So think about that. It's not about the speed. It's about the road itself just completely getting twisted. So how on earth does that work?
Okay, to get our heads around this, we have to throw out our old ideas about gravity. We've got to start thinking about something called the fabric of space.
So the old way of thinking, right, is that gravity is a pull. The Earth pulls you down. The sun pulls the Earth. But what Einstein figured out was totally different. Gravity isn't a pull. It's a bend, a curvature. Big, massive things aren't pulling other objects. They're literally bending the space around themselves. And what is it they're bending? Well, it's this thing called space-time. The best way to picture it is like a huge, stretchy rubber sheet. Now, if you put a bowling ball in the middle of that sheet, what happens? It makes a dip, right? Well, that dip is gravity. That's it. And that's why planets orbit the sun. They're not being pulled by a rope. They're just following the curve that the sun's massive weight creates in that cosmic sheet. All right, so if a star is like a bowling ball making a dip, what's a black hole? Well, that's not a dip. That's a well, a bottomless pit in space-time. Yeah, this really says it all. You take an incredible amount of mass, like way more than our sun, and you crush it. You condense it down into a space so small it's basically zero. What you get isn't a gentle curve anymore. It's a puncture, a deep, folded hole in the universe itself. So why is the bend so extreme? It boils down to two things. First, these are, hands down, the densest objects anywhere in the universe. And second, all that incredible mass is squeezed into a single, tiny point. You put those two things together, and you get a gravitational pull that is just off the charts. Okay, so we've got this totally warped, twisted piece of space. So what happens when light, which always wants to travel in a straight line, comes flying by? It's actually pretty simple when you break it down. First, you've got to remember that light is lazy, in a way. It always takes the shortest possible path. Always. Step 2, we know the black hole has just completely mangled the space around it. So what happens in step 3? Well, the shortest path isn't a straight line anymore. The shortest path is now a curve, and light has absolutely no choice but to follow it. And this idea that light is forced to follow a bent path, that leads us to the most famous and, frankly, the most terrifying part of a black hole, the point of no return. We're talking about the event horizon. Now, this isn't some physical wall you could bump into. It's a line in the sand. It's the exact point where that curve in space-time becomes so ridiculously steep that literally every direction is down. Think about that. Go forward, you go in. Go left, you go in. Try to turn around and go back, you still go in. Every single path points to the center. There are 0 paths that lead out. And that's it. That's the reason black holes are black. It's not that they're dark objects. It's that light itself falls in and can't get out. Once it crosses that event horizon, its path is so bent, it just spirals down. It literally can't resist the fall. And of course, if the fastest thing in the universe can't escape, then absolutely nothing else can either. No information, no signals, nothing. So when you think about it, a black hole isn't just some weird object in the universe following the rules. It's a place where the rules themselves seem to just break. It fundamentally changes the game, twisting space and time into something unrecognizable and trapping light forever. It really makes you wonder, what else is out there that we just don't understand yet?